All right, so here's the answers for how you do target 51 on the ART, which is graphing a variety of functions. And for each one, what you're going to want to do is make a table of values by picking some x values, plugging them into the equation, and getting the corresponding y values. And then you plot the points to fit the curve. So I already kind of showed you how to do that here for -2. The table's already set for you. If I were to do that for 0, you just get 0 cubed minus 2 times 0 squared minus 3 times 0 plus 5. And, order of operations, you'd cube first. Well, any 0 cubed is 0. 0 squared is 0. So you end up with basically just 5 here. You can keep doing that. You can use your calculator like I did here with the -2. Just remember, when you put in the -2, you use parentheses around that. And then the other way, you go to your y equals, you can type in the equation. And then you can set up a table, started at -6, going up by 1s, hit second graph to view the table. And this is probably the fastest way to complete this, or at least to check your work. So for -6, you should get -265. It double checks with the -2 and the and the 0. There's a few other points on here I could plot. I see -1, 5 is on there, so I can add that one to my graph or my table if I want. And then to get my other ones, I can just scroll down. There's 0, 5. I can add the point 1, 1. So that one's not in my table, but I can add that. 2, -1. 3, 5 isn't on my table, but I can add that one. 6, 131. So what these big numbers at the end is telling me, and if I do the zoom 6 to view the graph, those big numbers at the end are telling me that at the left end it's going down really fast, and at the right end it's going up really fast. So now I'm just going to plot these other points, and the few extras that I put in there. So I have -2, -5. From that point, I know it's just going down really fast. I have 0, 5, 2, -1, and 3, 4, 5, 6, 231. So it's telling me after that it's just going up really fast. And if I wanted, I could plot in some of these other points like -1, 5, 3, 5. You can see my curve there missed a little bit. 1, 1. And then I'm just going to connect the dots there. And I can see my curve. Make sense? It's kind of a more advanced version of making a table, plotting the points, connecting them with a curve. This is kind of a fancier curve. All right, the second one should be familiar. This is a linear equation. So I could do any of those same methods. I could put the equation in my y equals. I could get my values from my calculator, like doing -2/3 times -2 minus 1. So I get 0.3 repeating. If I want to leave it as a fraction, I could convert it to a fraction there. So I'd get 1/3 here. I can just do it by hand. If I put 0 in there, -2/3 times 0 minus 1 is -1. If I put -3 in there, -2/3 times -3 minus 1 becomes -6/3 minus 1, which is positive 6/3 minus 1, which is 1. And if you want, since it's linear, you can then start looking for the pattern. I can think of 1 as 3/3. So here's my 1, 1/3, -1. I just changed those. I can see here it's decreasing by 2/3 each time, because that's my slope. So the next one's going to be 2/3 less than that. So if I take -3/3 minus 2/3, that would be -5/3. And then minus 2/3, -3/3 minus 2/3, -5/3. Right here. Oh, no. -3/3. Let's do it this way. -2/3 times 2 minus 1 oh, it's -7/3. That, I see what I was doing here. They skipped a value. The next one would be -5/3. But that would be for when x is 1. And this jumps to 2. So that's why this one is 7/3, -7/3. And then the next one would be -9/3, which is -3. So however you want to do that and get those values, whichever way is easiest for you, and then you just plot them. -3, 1, 0, -1, 3, -3. Notice how I'm not even bothering to plot the fraction ones. And then since it's linear, you just take a straight edge and connect those with a straight line. Try to get your line to hit the point. That's it. So again, you can get those values by hand. Using your calculator, you could put them in your y equals and make a table that way. So there's a linear. The next one has a square root in it. And this one doesn't have a table. So that's where you're going to want to make the table. And normally I would tell you to pick some negative values for your table. But what's going to happen when you try to take the square root of -4? It says what? Error. If I take square root of -4 minus 5, it will say error because you can't take square roots of negative numbers. So what that means is I'm not going to get any values until I get to 0. Then I'm going to get some values. Now the other thing I can do is, so like if I did that one, square root of 0 is 0, minus 5 is -5. Square root of 1 is 1, minus 5 is -4. If I were to do 2, the square root of 2 is a decimal. So I'd end up with a decimal answer here. What I'm going to do is I'm going to skip to the next one that's not going to be a decimal, which is the next perfect square. Square root of 4 is 2. 2 minus 5 is -3. What's the next one in the list? It's the next number you know the square root of. 5, 6, 7, 8, 9. So I'm just going to skip to that. Square root of 9 is 3. 3 minus 5 is -2. So now I plot these points, 0, -5, 1, -4, 2, 3, 4, -3, and 9, -2, and I connect them, and this is the type of graph I will get. It doesn't go any further past that point 0.5. Okay? Number 17, this one is an exponential equation. You might recognize it as being in this form. So there's no table again, so you've got to come up with that table. Could start with the easiest one. If I put 0.6 to the power of 0, that's 1. anything to the power of 0 is 1, times 2 is going to give me 2. And then the next one, 2 times 0.6 is going to be 1.2. If I want to get the next one, I could do 2 times 0.6 squared. Oops. Squared. So I get 0.72. What's going to happen as I continue going this way is they're going to get closer and closer to what? 0. Now if I go the other way, 2 times 0.6 to the power of -1, these numbers are going to get bigger. I'm just going to put decimals in here, like 3.3. And I'm actually going to make a jump here just to speed things up. I'm going to go to my y equals, put in that equation. Remember to use caret, then x. And then I'm just going to look at a table. Let's start it at -4. Whoops, second y window, -4. So -3 is going to be 9.3, 5.6, etc. So now I just start plotting these. -3, 9.3, estimate where that is. -2, 5.6, -1, 3.3, 0, 2, 1, 1.2, 2.7. And then remember, your curve is going to approach the x-axis because these numbers get closer to 0. Oops. Anytime you are graphing an exponential curve, it's going to curve towards the x-axis at one side or the other. So make sure that curve doesn't cross the x-axis there. All right, so we did a linear, we did an exponential, we did quadratics in Target 48. We did some other ones like square root and the one with the cube in it. And then the last type on here is called a piecewise function. With a piecewise graph, there's going to be two equations, and they're just pieced together. So the two equations, here's one, and it says when to use that. So use that when x is less than 3. So I'm going to start by thinking about what that graph looks like. It's got an x squared in it, so it's going to be a parabola. It's got a negative in front of it, so it's going to open down. And then it's going to be shifted up 5 by the +5. So right away I can tell that these two graphs have that upside down parabola. This one is, these two are facing the wrong way. So I've eliminated C and D. Now the other part of the equation is the y equals 3 if x is greater than or equal to 3. Y equals 3 is a horizontal line at a y coordinate of 3. So that's this part of the graph. So now the thing I have to ask, these two graphs are the same except for one thing. Closed circle here versus open circle here. So that's the start of that graph. When x is greater than or equal to 3, we should be using this graph. And notice how it includes the 3. It's greater than or equal to 3. So at 3, which one of these graphs is using this one? A or B? It's filled in there, so it's A. This one, when x is 3, is filled in on this graph. So when x equals 3, it would have been using the top equation. So that would be wrong. So the correct answer is graph A. All right, so remember, in general, to meet target 51, for each problem you should show a table of values. You can pick the x values if they're not there. Put them into the equation to find the y values. And then plot the points, connect them with a line or a curve.